Okay, today we're going to demonstrate a PIP or PEEP pilot regulator for a dome-loaded device in a ventilator system. And this one specifically is the PEEP pilot valve, and this will generate a pneumatic signal which can go to a dome-loaded device to control airflow from the patient. Currently we have a pressure transducer displaying pressure controlled by this pilot valve in a millibar pressure. And we have this bank of rotometers. We are only going to evaluate this rotometer and this rotometer, which this one on the left is cc's per minute of air volumetric flow, and the one on the right is representing flow in liters per minute. So we've kind of balanced the system here at 1 liter a minute and roughly 25 millibar of set point. This represents typical peak pressures for PIP set points. And I'm going to demonstrate a flow change here, so we're going to go from 1 liter a minute up to 2. And we've done that, and we see less than 0.1 millibar of pressure change. There's a little bit of, I guess, delay in the pressure transducer, but the pilot pressure is still fairly stable here. And I'm going to go ahead and drop it. Okay, so we've done roughly a 10 order of magnitude change in flow. We've gone from 1 to 2 liters a minute down to 150 cc's, which represents 10 order of magnitude in flow consumption change. Fortunately, what this also represents is a 100 order of magnitude change in supply pressure. It simulates that, of course. So if what this is to demonstrate is that the pilot pressure sent to the PIP pilot valve, or PEEP pilot valve, excuse me, is very robust to supply pressure changes and or flow changes. We see that the set point here has not changed at all. It's still 24.8 millibar, which was what was displayed at the beginning of this test. So I'm now going to change the set point by adjusting this screw on top. This changes the set point of the valve. I'm going to go to a low set point here. Typical low PEEP pressure pilots are on the order of 5 millibar. So we'll get approximately in that range. Here we are. So we have 5.3, 5.4 millibar set points at 150 cc's a minute of flow. We're going to increase that to the order of magnitude of liters per minute, which simulates a 10x change in flow or a 100x change in supply pressure. And we've gone from 5.3 to 6.3 millibars, so we had a 1 millibar change across a order of magnitude change in flow. So this shows that the device is very robust and still maintains a high degree of accuracy across a very wide range of pressure and flow conditions.